So here we go. So today what we're going to do is we're going to look at how to find the slope when we don't know what x is. Right? So we're given the y value, and remember another way of saying y is saying f of x. F of x and y mean exactly the same thing, right? So what we're going to do is look at how the process for finding the slope when we have other information. Because last time we found it when we had the x values. It was quite easy. All we had to do was differentiate, plug the x values in, and get our slope, right? But this time, we're going to be given y values, which means we're first going to have to find our x values in order to make it work. So, first step, substitute the y value, and again, that could also be called f of x. They'll give it to you in both ways. The f of x into
what's the title of this?
The original equation. Yeah, finding the slope when you know y. Last time we found the slope when we knew x. This time we're finding the slope when we know y. Now, I'm going to tell you that the most difficult part of this entire course is knowing when to use which piece, right? If you're looking for x or y values, that's always the original equation, or the original function. If you're looking for slope, that's always the what? The derivative. Okay? So keep in mind what pieces that you're looking for will tell you what to use. And you're going to have to bounce back and forth throughout this course when we're working with problems. Sometimes you'll be working one way, sometimes you'll be working backwards. So keep in mind when you're using the original equation or the original function and when you're using the derivative. Okay? So, anytime you're looking for x or y, that's which one? The original. Anytime you're looking for the slope, that's the derivative. Okay? And we'll add to that as we go. But it's using the wrong thing in the wrong place is the probably the biggest issue you're going to have in this course.
When we're finding x, when we substitute x into the derivative, to find y.
Well, no, we were finding the slope. Yeah, the gradient. Okay, so substitute y into f of x into the original equation. Solve to get x value or values. Because remember, many of these are going to be quadratic, so you're going to have two x values for the same y value. Because remember the parabola, when the parabola goes up like this, you get x values here and here that are the same. So you'll get two x values, okay? Or they can be vastly different x values. Morning. Okay? So you're just going to solve to get the x values. Then you're going to take the derivative. Thank you. Okay? And of course, anytime you're taking the derivative, we mean the derivative of the original function. Then substitute x to find slope or gradient, whichever one you want to call it, is perfectly fine with me. Now, what if I get two x values? Then I'm going to have to do it both. I want this. That means that means for that particular y value, then that curve is happening twice, so you can get two different slopes. Because remember, we're talking about curves here generally. Okay. You can have more than one x value. And you have to solve for each. Which is why we did the algebra section before this, so that you know how to solve all of those equations. Yeah? Okay? So, simply substitute the y value, also known as f of x, into the original equation, solve it to get your x values, then take the derivative of the original, right, and substitute x into that derivative to find the slope. And if you have more than one x value, then you need to find all of them.
How do you know which one's right?
Pardon me?
How do you know which x value is right?
They're both right, because remember, if it's a curve and you have your y value, whatever your y value is, it can cross twice, right? So
is that just like looking for the slope where it's like
wherever y is some number. For example, like here, say you have a parabola like this, okay? And this is the x-axis, right?
Yeah.
Okay? And we're looking for the slope where y equals 1. Well, let's pretend that this is 1. Well, that happens twice, doesn't it? So we're looking for the slope at both points. And if both points are the same, then you're going to get two different slopes. It'll be the same number, but what is the parabola doing this side? Well, it's going up, so it's not negative. It's what?
one will be negative.
One's going to be negative, the other's going to be positive. Okay? Now, you don't have to draw the graphs, but if you want to draw the graph just to kind of give yourself a visual, it might help, but most of you are fine with just plugging it in and doing the work. All right, so here we go. We're going to do which ones?
One.
We're going to do the evens.
Oh, sorry, the evens.
There you go. There you go. All right.
2.
So our first function, number 2, y equals x to the third, where y equals 8. So again, hey.
Is this on page 21?
So I just simply put the 8 in place of the y. I need to get the x completely by itself, but it's not. It's x to the third. So how am I going to get rid of an exponent of 3? Take the cube root, right? No logs. Take the cube root. But if I take the cube root of one side, what? Take the cube root of the other one. What is the cube root of 8, guys? 2. And the cube root of x to the third, remember that those things are opposites, so it just eliminates the exponent and the index, which gives you just a plain old x. So x in this case is what? 2. No pluses and minuses or anything like that. It's just plain old 2. Okay? When you take the cube root. All right. That's a little different when you take the square root, right? If you take the square root, you get positive and what? Negative 2. So here we go. Now, second step is to take the derivative of our original function. So, dy dx. The number in front is a 1. So 3 times 1 gives me what? 3. X to the 3 minus 1 is x to the second, or x squared. Okay? So that's the derivative. Now I'm simply going to take the x value that I just found and plug it in there to find the slope. So equals 3 times 2 squared. Squaring the 2 gives me a 4. And 3 times 4 gives me a slope of 12. Okay? Let's see if they... the derivative. 3 times 1 gave us the 3. Remember, you multiply times the coefficient and then subtract 1 from the exponent. Okay? All right. So one more layer, but it's something we've done before. Okay? We like doing things we've done before. Any questions about this one, guys? All right, let's move on then. Can they all be? They're all that easy, trust me. Okay, here we go. So look at number 4. F of x equals x squared minus 9, where f of x equals 0. Right. So f of x is the same as saying y, right? So I need to find my x. So finding the x values is the first job. So to do that, I'm simply going to replace f of x with the number they give me, which in this case is 0. So we get x squared minus 9, which makes that a what kind of equation? Quadratic equation, right? Which we could use to solve the quadratic formula, but this one factors easily because it's two terms, and that thing is the difference of two squares, you bet. So we're going to get 0 equals x squared is x times x. Guys, come on. 9 is 3 times 3. Get a positive and a negative, right? Remember that? That's the one that has the pattern, the difference of two squares. Set each one of those equal to 0. And solve, we get x equals negative 3 and what? Positive 3, yeah. It's always the same number, but you get one positive, one negative.
You don't have to do that writing there, do you?
No, I'm just trying to remind you, those of you who need it. Okay? You bet. If you can see x squared minus 9 and you know it's going to be positive 3 and negative 3, that's all I need to know. Okay? You show as much or as little work as you need to. Now that I know those, I'm going to take the derivative of my original function. So that's a 1. 2 times 1 is 2. X to the 2 minus 1 is x to the 1. And the derivative of 9 is what? 0. So it's just gone. So the function is just 2x. But I have two x values. So I need to find the slope for both of them. So it's 2 times negative 3, and then the slope is 2 times positive 3. So that gives me negative 6 and what? How easy is your life right now? Oh, it's going to stay that way. No. It's really not. It's love it. I love this is my favorite part of this course. Okay, we ready? Let's look at some more, kids. Try to mix it up. Okay, here we go. Come on. So first, guys, do I know my x values? No. So I've got to first find my x values by replacing f of x with the number they gave me. Now, looking at that, we know it's what kind of equation? Quadratic. So we're going to, and the first step for any quadratic, no matter what method you use for solving it, is to set it equal to what? 0. Now, you show as much or as little as this as you need, but you know for the notes, I always show every step. So subtracting the 50 from both sides, they're so nice to you. It gives you another difference of two squares, right? Yeah, so it's 0 equals x plus 7, x minus 7, and when you solve them, you get a negative 7 and a what? Positive 7. So those are my x values, yeah? Now, I need to find the derivative of my original function. So f prime of x equals, again, there's a 1 in front of there. So 2 times 1 is 2. X to the 2 minus 1 is just plain old x. And the derivative of 1 is 0, so who cares, right? Okay. Now we're just going to plug in our numbers. 2 times negative 7 and 2 times positive 7 gives us negative 14 and positive 14. Happy?
Wait, did you say y equals or like what the?
No, the gradient equals or m equals. Actually, in the back of the book, all they want is the number, but you remember these are the gradients. So these are not y values, they're not x values, they're m values, right? M, just a weird letter, doesn't, so I don't know.
Oh, we searched this out one time.
Did you look it up and find out why M?
That's like really weird. I think it might be Latin or something.
Latin or German, yeah. Okay. Come on, guys, I'm losing you. f of x equals 2x minus 1. And you have to behave today because remember they're touring. Oh, I'm going to stop this recording. It's not the building, it's you're paying for the quality of the teaching. Sorry. There you go. Okay, first of all, it says that where the curve crosses the x-axis.
So 0. Can we do three?
No, you're not even supposed to be looking at number 3. You're supposed to be working with me. All right, come on. Crosses the x-axis. Once we've done all of our examples, then I'll go back and I'll answer your questions about weird twists and stuff. But I'm not going to do them. Yeah, what happens what is y if you're crossing the x-axis?
0. Wait, no. Yeah.
Can you go up or down any if you're on the x-axis?
Yeah.
No. So it's just so f of x is simply 0. Right? If you think about if you're on the x-axis, you can't go up or down any. Right? So that means y has to be 0.
So you don't need to expand it, do you?
No, and it's already factored for you, isn't it?
Expanded it. And it was like, why? I didn't like do it. Factor it again.
So setting each one equal to 0 and then solving gives you x equals positive 1/2 and negative 3. Right? Now what we need to do is find the derivative of our original function, in which case we must expand it. Right, Shreya? Okay?
Yeah. Okay.
So you're okay. So 2x times x is 2x squared. 2x times positive 3 is positive 6x. Negative 1 times x is negative 1x. Negative 1 times positive 3 is negative 3. Combine your like terms. Okay? Now that I have it expanded, I can take the derivative. But unless I can never take the derivative if I have the brackets, right? So you always have to expand it. So taking the derivative of the function, remember it's take the exponent times the coefficient, subtract 1 from the exponent. So the first one is 2 times 2, which is what? 4. X to the 2 minus 1 is x to the first. Here, the exponent on that x is a 1, so 1 times positive 5 is positive 5. And the derivative of x, of any plain old x, is always what? 1. And I don't need to write the 1 because I have a 5. And then, of course, the derivative of any constant is 0. So it just goes away. Okay?
In the second to last line, is that 5 next to the 5 is?
No, it's an exponent of 1. Because as I was taking the derivative, I just write the 1s in there just to show you. Okay? Now let's plug it in to both of them. So the first one is 4 times 1/2 plus 5. The second one is 4 times negative 3 plus 5. Solving the first one, 4 times 1/2, half of 4 is what? 2 plus 5 makes 7. Over here, 4 times negative 3 is negative 12. And negative 12 plus 5 is, pardon? Negative 7, which I expected because this was what kind of function? Quadratic, which means it's going to be the same number, different sign. Right? Yeah. Okay? Because remember, quadratics are symmetrical, so you're going to get the symmetry. All right, one more. And then you're on your own. F of x equals, never leave you on your own completely, x squared over 2, where f of x equals 8. Do I know my x values? No. So that means I have to first solve it to get the x values. So plugging in 8 equals x squared over 2. I need to eliminate those fractions first. When I'm solving any equation, eliminate the fraction by 2. Right, because the opposite of divide by 2 is multiply by 2 to both sides, right? 2 times 8 is 16. Over here, the 2's will simply divide away, gives you x squared. Now, I could set it equal to 0 and get the difference of 2 squares, but notice I just have a number and a square, so I can simply unsquare both sides by taking the what? Square root. The square root property. Good. Over here, it's going to just divide away and give me the x, and the square root of 16 is what?
Plus or minus 4, negative 4.
Yeah, there you go. Remember, you want both values, so you get positive 4 and negative 4. Okay. Now let's take the derivative of our original function. But before I do that, I need to clean up that original function first. Why? Oh, I just pushed the wrong button. Again, why, guys? Why do I have to clean up the function? Yeah, the fraction. So that should be 1/2 x squared. Yeah? Right? Okay. Always try to get the function, get the numbers in front of the x squared. X. So now let's take the derivative. 2 times 1/2 is 1. X to the 2 minus 1 is x. So it's just x, right? You can do it over it, yeah. All right, did you have a question about? Got it, okay. Now, if f prime of x is just x, and x is positive 4 and negative 4, what's m? There's nothing but an x to do, right? So just replace it with x and you're going to get what you're looking for. Because what you're looking for is the gradient, which is the slope, which is m.
After you put the 8 into the x,